Let's look at how to export publication quality scene images in SeaDAS. The focus will be on saving out image files, but let's first create an image to demonstrate this with. I have a PACE OCI Level 2 Ocean Color Biogeochemical Properties file loaded in the SeaDAS, but this video on image export will apply to any file which you can visualize in SeaDAS. Open the chlorate band, add its landmask, click the soft button to add some key graphics. This is the Argentine Sea. Let's zoom in on this bloom and crop it down. Select Image Crop. Press OK. This creates a new file. Open its chlorate band. Click the soft button. Let's fine-tune the zoom and frame the image in the view window to reduce some of the extra margin space. And now we have a decent scene image to export as a file. The color bar legend is slightly blurry. That's because this is cropped down to a small file. We'll address that shortly. Right-click on the scene, select Export View as Image. You may need to expand the form to see all the buttons. The default combination of View Region and View Resolution means that the exported image will be the entire view window and that the resolution will match that of your computer screen. This is essentially a screenshot. The dimensions of the file which will be created are shown here. In this case, this will be too small to produce decent text graphics. If you did go with these options, your output image would look like this. Zoom in and you see that the text graphics are pixelated. For clearer text graphics, you'll need to export this at greater pixel dimensions. So let's select User Resolution and then specify custom dimensions. We'll go with perhaps 3500 pixels for the width. The other dimension gets auto-adjusted, retaining the original aspect ratio to avoid stretching the image. You can go lower or higher depending on your needs, be it for a small publication image or for a huge poster. There's several file formats available. PNG is lossless and compressed and should be fine. But do stay away from the smaller, lower quality JPEG format, especially if you have any text graphics. With alpha channel off, there will be no transparency, and your background color, in this case white, will be in your image. With alpha channel on, then transparency is enabled and the background color will be gone and transparent. Either way can be quite useful. We'll leave alpha channel off to retain the background. Give it a name and save it. Open the image file, zoom in, and we see decent text graphics. This is because these graphics are vector data and can adapt to the resolution of the exported file. However, the color bar legend graphics are a bit blurry. This can happen because the color bar legend is a raster image layered onto and bound to the grid resolution of the source file, in this case the small size cropped file. So for a clear color bar legend, especially with small files, you'll need to export the color bar legend separately as its own high-resolution file. To do this, right-click on the image, select Export Color Bar Legend, click Properties. Here are all the color bar parameters. Leave it at Scale to File Size. And the file size in pixels is here. That's the number of pixels along the length of the color bar. The default of 2400 should be fine, but you can increase it if needed. Select OK, then Save. Open the saved color bar legend file, and we see a color bar with nice crisp labels. Then in software such as PowerPoint, you can integrate the scene image with this clear color bar legend. If your goal is to export an image which is exactly the size of the source data, with a 1-to-1 correspondence between the source pixels and the exported pixels. Then, in image export, go with full scene at full resolution. Full scene uses the exact dimensions of the data file. It includes all the pixels of the data scene and excludes any of the graphics which may lie outside of the data scene. For file format, PNG works well. GeoTIFF is only applicable when you use full scene. Give it a name and save it. Open the saved file, and we see it is the full data scene, with no margin graphics, and each pixel corresponds to a source data pixel. Lastly, for extremely small scenes, perhaps a few hundred pixels on a side, you can get distorted grid lines, pixelated land masks, and a blurred out color bar. And this would take a bit more effort to resolve. Increasing the size of the source file by upsampling and mapping it with the SeaDAS Science processors, L2Ben and L3 MapGen would be one solution. Here's an example of what that might look like, with high-resolution land and graphics layered over the upsampled imagery. So keep that in mind, and we'll look into that in a future video. And that's some pointers on how to export publication-quality scene images in SeaDAS. To get answers to SeaDAS questions, visit our forum and websites. Those links and any addendums to this video will be posted in the description below. Thank you for watching, subscribe and stay tuned for more SeaDAS tutorial videos.